Today, in this video, I will explain the effluent detoxification from pulp and paper industry using microbial engineering and advanced oxidation techniques. Paper is one of the largest commodities that are used in our daily routines in various forms, such as newspaper, office work, school, and many more. The pulp and paper industry generates a huge amount of effluents in the form of sludge and wastewater. Therefore, effluent treatment is required before proper disposal in order to check the toxicity of the surroundings of this waste. Bioremediation is an innovative approach to make the effluent less toxic and safe for disposal. Microorganisms help in the removal of this effluent by degrading them into the less toxic elements and reducing the needs of chemicals for the remediation steps, such as Saccharomyces cerevisiae, can use pulp and paper sludge for the production of ethanol through the simultaneous saccharification and fermentation process. System biology and engineering are used to engineer naturally occurring microorganisms for the increasing their efficiency of the effluent degradation. From the figure 1, it shown microorganism in treatment of effluents. Omic-based technologies also approach includes the study of genomics, metagenomics, metabolomics, and proteomics. Genomic studies concentrate only on a single organism, while metagenomics analyze whole microbiota. This metagenomic study help in deciding the consortial selection for the bioremediation. Proteomics approach study the involvement of proteins in specific conditions. Aromatic hydrocarbons and heavy metal bioremediation has been studied using proteomics approach. Metabolomic approach, which identifies metabolite at a special point of time, also helps in finding the attenuation of the pollutants. Apart from these system biology tools and molecular biotechnology prospects, computational tools also play an important role in the selection of the modified approach for the effluent bioremediation. From the figure, computational tools help in generating the data of different pathways and interlinking of different genes and their products. Computational tools and artificial intelligence-based tools are used to design enzymes based on different properties to increase their substrate binding efficiency, thermoset ability, and activity. Artificial intelligence-based tools helps in the stimulation of integrated parameters to reach a conclusion in lesser time. Artificial neural network (ANN) helps in the modeling of complex processes and predict their pathway. ANN has been applied successfully to model the simultaneous biogas production and wastewater treatment. But sometimes the toxins present in the effluent are higher in amount and they are not reduced by the biological treatment alone. So, for the exclusion of such obstinate organic compounds, some advanced oxidation processes are utilized. Advanced oxidation processes such as the Fenton process can be applied to reduce these organic pollutants. Fenton process can reduce the chemical oxygen demand of biologically pretreatment wastewater. Various kinetic models applied for the verification indicates that this degradation occurs in two steps. First, rapidly, in which aromatic constituents are converted into the acids. Acids are then degraded slowly in the second step. The photofenton process uses the mechanism of the photocatalysis to regain ferrous ions. This study indicates that reusable and highly stable photocatalysts can improve the use of the photofenton process in the wastewater treatment. Another variable of the Fenton process, which has recently been applied for the treating pulp and paper industry effluent, is the electro-Fenton process. In this process, H2O2 is generated by the reduction of the oxygen at cathode generally made up of the carbonaceous material, and H2O2 reacts with the catalytic quantities of the ferrous 2 plus to produce the hydroxyl radical in the solution. This produces OH react swiftly with the organisms and carries out their oxidation. The electrophantom process is superior to the conventional phantom process as it generates H2O2 continuously with the use of the electricity and also regenerates ferrous 2 plus with the help of reduction of ferrous 3 plus at the cathode. Using the electrophantom process, high removal of the total organic carbon can be achieved. The efficiency of the electrophantom process depends on the use of the suitable anodic process and an increase of current density using suitable cathode. The use of advanced oxidation techniques can help in the reducing the toxicity of the effluents, but valorization techniques help in the sustainable disposal and proper use of the pulp and paper industry effluents. Valorization techniques such as clinker preparation, sorbent production, and bioethanol production can help in the reducing waste production as well as resources generation. Phantom process and its variables are efficient in the reduction of the toxic compounds from the effluents. Apart from them, advanced oxidation processes like ozonation, sonication, electrocoagulations are also used for the removal of the toxic compounds from waste. In the conclusion, pulp and paper industry produce an enormous amount of waste material. The bioremediation or proper disposal of this waste is carried out by different biological, mechanical, and chemical processes. Among these processes, it is found that a single process did not able to remove all the components of waste effluent altogether. Hence, it is observed from these studies that integration of biological treatment with advanced oxidation process is a sustainable way ahead. The residue after the treatment process can be valorized using different techniques of clinker preparation, sorbent production, biochar, and biofuel productions. This will help in zero waste production strategy for the pulp and paper industry and make it environmentally sustainable.